All right, so basically today we're going to be talking about what we call counting techniques. So a lot of questions like how many ways can this happen? How many different, how many different choices are there? How many different combinations are there? So in the first section, we're talking about the fundamental counting principle, which is often also referred to as the multiplication principle, because it basically just involves multiplying a bunch of numbers together. All right. So, for example, number 1 says a car model comes with the following choices. We have 9 different colors, with or without air conditioning, with or without sunroof, with or without automatic transmission, with or without a spoiler, and with or without anti-lock brakes. In how many ways can the car be ordered? Okay, so we're just going to take all of these and multiply them together. So we have 9 different colors, and then every time it says with or without, that's going to be, that's 2 options. Either you have it or you don't. So that's 2 options. So, with or without air conditioning, sunroof, automatic transmission, spoiler, anti-lock brakes. Okay, that's 5 things, right? So, okay. So it's going to be 9 times basically 2 to the 5th power. 1, 2, 3, 4, 5. So 9 times all of those 2's. And that's going to give us our answer. And like I said, we can also just type in 9 times 2 to the 5th power. Same thing, either way. That's 288. All right. All right, so number 2 says you are about to take an 8-question multiple choice test. Each of these questions has 4 possible answers, A, B, C, or D. How many ways can you answer the test if you put an answer for each question? Okay, so there's 8 questions on the test. So, and for each of those, you have 4 possible choices. So you have how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Okay, or in other words, 4 to the power of 8. And that's going to give us our answer. So that is 65,536. All right, number 3 says a social security number contains 9 digits. So in that format, how many different social security numbers can be formed using any numerals from 0 to 9? Okay, so from 0 to 9, that's 10 options. So in other words, that is 10 to the power of 9. So it's going to be basically a 1 followed by 9 zeros. So that's like a billion, right? All right. Number 4 says, how many different 4-digit alarm codes can be formed for a house alarm? The first digit must be a 2, 4, or 9, and all the other digits can be any number. Numbers can be repeated. Okay, so it's a 4-digit alarm code. All right, so the first digit has to be either a 2, a 4, or a 9. So that means that there are 3 options for the first digit. Okay. And then for the rest of the digits, it can be anything. So there's 10 options for each one of those. Okay. So just multiply all those together. That's like 3,000. Okay, number 5 says, how many 5-character license plates can be made if the first 3 characters are letters and the last 2 characters are numbers? Repetition of characters is allowed, but the first letter must be a P, W, Q, E, L, or K. All right, so it's a 5-character license plate. Okay, so 1, 2, 3, 4, 5. So the first three characters are letters. Now the first letter must be one of these. So that's 1, 2, 3, 4, 5, 6 options that you have for the first character. All right, so the first three are letters. So there are 26 letters in the alphabet. So the second character can be any one of those 26 letters of the alphabet, and the same thing goes for the third character. And then the last two characters are numbers. So that means there's 10 options and for each of the last two characters. Because 0 through 9, that's 10 options. All right. So we just have to multiply all those together. Six times 26 times 26 times 10 times 10. So 405,600. All right. Any questions so far? All right. Number 6 says telephone numbers in the United States begin with 3-digit area codes followed by 7-digit local telephone numbers. Area codes and local telephone numbers cannot begin with a 0 or 1. How many telephone numbers are possible? Okay, so you've got your 3-digit area code. 1, 2, 3. And then you got your telephone number, which is 7 more digits. 1. All right, so the area code can't have a 0 or a 1. So instead of, so if you take everything 0 through 9, that's 10 options. But if you take away 2 of those, that leaves you with 8 options. So there's 8 options for the first digit of the area code, and there's 8 options for the first digit of the phone number. Everything else has 10 options. So right here you have 8, 10, 10, 10, 10, 10, 10. Multiply all those together. So it should be like 64 and then 8 zeros, I think, basically, right? It's like 6.4 million.
How do you get that? What can you say on again?
So you have your 10 digits. So that's why I write the 10 blanks. And then, so we're talking about a telephone number. So it says the area code. So you've got the 3-digit area code, and then you have the 7-digit local telephone number. It says the area code and the phone number can't begin with a 0 or a 1. So the first digit of the area code has those restrictions, and so does the first digit of a telephone number. So normally, if it can be any number like 0 through 9, that's 10 options, right? So if you take away 2 of those, the 0 and the 1, you're left with like 2 through 9 are the options. So that's 8 options. So you have 8 options for the first digit of the area code. You have 8 options for the first digit of the local number. And then all the other digits can be anything. So you have 10 options for each of those. And then you just multiply all those together.
So the numbers are always going to be 10.
Well, if it can be any numeral from 0 to 9, then that's 10 options. And then if it has any restrictions, then you can take away from that. But yeah, if it doesn't have any restrictions, then yeah.
Because like on number 5, we use 10 and
26?
yeah.
Because it's so 10 is because it can be any numeral from 0 through 9. Because it says the first 3 characters are letters and the last 2 characters are numbers. So the last 2 characters are numbers, so that's why it's 10, because it's anything from 0 through 9, because it didn't say there were any restrictions on the numbers.
Okay.
Yeah, and then 26 for the letters, you know, if it can be any letter of the alphabet, that's 26, because there's 26 letters in the alphabet. So 6,400,000,000. Yeah, so there's a lot of really big numbers in this chapter. All right, number 7 says shoppers in a large shopping mall are categorized as male or female, over 30 or 30 and under, and cash or credit. In how many ways can the shoppers be categorized? Okay, so male or female is 2 options. And then over 30 or 30 and under, that's another 2 options for that category. And then cash or credit, that's 2 options for that category. So 2 times 2 times 2 equals 8. So the answer is 8. All right, number 8 says there are 8 horses in a race. How many ways can they finish first, second, and third? All right, so we're talking about the top 3 finishers. So there's a total of 8 horses in the race. So the number of options for which one comes in first is going to be 8 options, 8 possibilities for which horse comes in first. So after that, whichever horse comes in first, there are now 7 horses left who could possibly come in second. And after that, there are then 6 horses left that could possibly come in third place. So we have to multiply 8 times 7 times 6, which is 336. All right, number 9 says a menu has 6 different sandwiches with 3 choices of potato, 3 types of salad, and 5 different beverages. How many different lunches can be ordered consisting of a sandwich, potato, salad, and beverage? So in this case, we're just going to do 6 times 3 times 3 times 5. That's 270. All right. Number 10 says, assume a postal code consists of 6 characters. Each character can be any letter from A to Z or any numeral from 0 to 9. How many postal codes are possible in this situation? Okay, so how many total choices do you have for each character? 36, because you have 26 letters and then there's 10 numerals. So 36 choices and there aren't any restrictions on it. So there's 6 characters. So you'd have 36 times 36 times 36. Oops. You just do that 6 times. So in other words, you could say it's 36 to the power of 6. So I think that's going to be a pretty large number. So 2,176,782,336. All right, number 11 says a lock uses letters A through H on the first dial and digits 0 through 9 on the second and third dials. How many possible codes are there for this lock? So A through H, so A, B, C, D, E, F, G, H. So that's 8 possibilities for that. So it's a 3-digit, and we have 8 for that. And then for the second and third, it's anything from 0 to 9. So that's 10. And that's 10. So that's going to be 800. All right. And then on that same problem, how many possible codes are there if the same number is not used twice? Okay. So it's mostly the same. The only difference is that third digit. So once you pick out the second digit, your third digit can't be the same as the second digit. So instead of 10 options for the last digit, you change it to 9 options for the last digit. And that'll change the answer to 720. number 12 says, in how many ways can a teacher seat 5 girls and 3 boys in a row of 8 seats if a boy must be seated in the first seat and a girl in the last seat? All right. All right, so there's 8 seats. All right. So there's 5 girls and 3 boys, and they want to put a boy in the first seat. So that's going to be 3 possibilities for the first seat. And then it also says they're going to put a girl in the last seat. So that's 5 options for the last seat because there's 5 girls. Okay, so let's say we select, since there's specifications for those 2, we would select those 2 people first. So now after we've selected those 2 people, how many people are left to be seated? So we started out with 8 people, we've seated 2 of them, so now we have 6 people left to be seated. So that means the next person, so I'll just go ahead and start back over here, there's going to be 6 people left to be possibly seated in that seat. And then there's going to be 5 possibilities for that seat. And 4 possibilities for the next seat, and 3 possibilities for the next seat, and 2 possibilities for the next seat, and 1 possibility for the last seat. So I'm just multiply all those together. So 10,800 possibilities. All right, so that's the end of 11.1. All right. So 11.2 is about permutations. But first we're going to learn real quick about factorials. So if you see a number with an exclamation point after it, that is a factorial. Okay, so this is something you can apply to really any whole number. So for example, if you see 5 exclamation point, we would read that as 5 factorial. And that is saying the same thing as saying 5 times 4 times 3 times 2 times 1. So So that's what 5 factorial means. Okay. And if you were to multiply that out, it would equal 120. All right. So if you had 16 factorial, that would be 16 times 15 times 14 dot, 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 right? And then 14 factorial is 14 times 13 times 12, etc., right? So basically, in this case, what you can do is you can cancel out, basically 14 and everything after 14, you can just cancel that out. Because that's all the same, right? Everything after 14 is going to be the same. So all of this would cancel out with all of that. So all you would have left to complete the problem is just multiply 16 times 15. So 16 times 15 equals 240. All right, so for number 3, 20 minus 16, you would do that in the parentheses first, and that equals 4. So then you just need to calculate 4 factorial, which equals 4 times 3 times 2 times 1, which equals 24. So 22 divided by 2 would be 11. And oh yeah, by the way, there is a factorial button in your calculator. So if you want to do 11 factorial, yeah, I should probably look this up, I think. Yeah. Okay. Yeah. Okay. So I'm trying to put it on my recording here. All right. So I'll just do this. All right. So on your calculator, you want to look for the button that says PRB. So first you're going to type in, if we want to do 11 factorial, first I'm going to type in 11. Then I'm going to press the button that says PRB. And then I'm going to use my arrow to go over to the exclamation point, which is the factorial, and then just hit enter. So it shows 11 factorial on the screen, and then just hit enter again to get the answer. So 39,916,800 is the answer. All right, so for number 5, you want to do 9 factorial minus 4 factorial. So I would just type that into my calculator. So first you're going to type in 9, then you're going to press PRB, then you're going to arrow over to the factorial button, the exclamation point, till it gets underlined, and then press enter, and then minus 4 PRB, and then again arrow over to the exclamation point. Right. Yeah, just put it all in at once. I keep catching something next to that. Yeah. So yeah, you just put it all in your calculator at once. And then just hit enter. So that is 362,856. Okay, so then we will talk about permutations. So when you're doing a permutation, you're always considering that the order of things is significant somehow. So when you see, small n, capital P, small r, what that means is that represents the number of ways to arrange r things chosen from n things. Okay, so for example, if you had 10 books and you want to arrange 4 of them on a shelf, how many ways could you do that? Well, that would calculate 10p4, and that would give you the answer. So they have the formula on here, but there's also, you probably noticed on your calculator, there is that function right next to the factorial button that says NPR. So we can just use that. Okay. So if we want to do 10p4, so in the calculator, we're going to start by typing in 10. Then you're going to go to press the PRB button again, right there. And then it already underlines the NPR option. So then you're just going to hit enter on that. So you have 10 NPR, and then you need to type in the 4. So that you can see on your screen 10 NPR 4, and then you just hit enter on that, and it gives you the answer, which is 5,040. And then just do the same thing for number 7, 20p8. So just type in 20, press the PRB button, hit enter, and then 8. So 20 NPR 8 equals a really big number. So 5,079,110,400 is the answer. So these can be calculated using the like the fundamental counting principle or the multiplication principle that we used in the last section, but this is kind of a shortcut for doing that. So number 8, so it says there's 12 horses in a horse show competition. The top 3 winning horses receive money. How many possible money winning orders are there for a competition with 12 horses? Assume there can be no ties. So what you can do is, so you're choosing 3 out of 12. So this would be like 12 NPR 3. So you calculate that, that would give you your answer. But you could also calculate it by doing, which we did one like this in the last section, 12 times 11 times 10. And either way, it's going to give you the same answer. So like on that case, it might be easier to even just do 12 times 11 times 10. But if it was like, you know, out of 100 and you're going to do, you know, 50 or something, then you'd have to do like 100 times 99 times 98, you know, all the way down to 50, and that would take forever. So you wouldn't want to do that. So either way you do it, the answer is going to be 1320. So number 9 says a license plate begins with 3 letters. If the possible letters are A, B, C, D, and E, how many different permutations of these letters can be made if no letter is used more than once? So that would be 5P3 or 5NPR3 Or you could also do it by 5 times 4 times 3. So that's going to be 60. Number 10 says, if there's 10 shows recorded on your DVR and you have time to watch 3 of them tonight, in how many ways could you watch them? So that's 10 NPR3. Which is all, it could also be 10 times 9 times 8. That's 720. All right, so then we have something called distinguishable permutations. So in how many ways can the letters of the word pizza be arranged? So in this case, what we want to do is, first of all, okay, how many letters are in the word pizza? So that's going to be 5. 1, 2, 3, 4, 5. Okay, so you would start off with 5 factorial, but then 2 of those letters are identical, right? There's 2 Z's. So those 2 Z's are indistinguishable from each other. So I'm going to divide this by 2 factorial. And that's going to be my answer. So 5 factorial divided by 2 factorial equals 60. All right. Number 12 says, how many signals can be run up the flagpole using 5 red, 4 blue, and 7 white flags? All right, so the total number of flags, 5 plus 4 plus 7 equals 16 total flags. So I'm going to start by doing 16 factorial. And that's going to be over 5 factorial times 4 factorial times 7 factorial. So when you put this in your calculator, you do need to make sure that you put parentheses around the denominator. Why? Because the numerator needs to be divided by that whole thing. So if you don't put parentheses around it, it's only going to divide it by the first thing. And then it's just going to think the rest of it is multiplying. So let me show you. All right, so we're going to start by putting in 16, then PRB, go over to the exclamation point. All right, so we've got 16 factorial in here. Okay, then divided by. All right, so if all I do is put in 5 factorial, 4 factorial, 7 factorial, it's going to divide by 5 factorial, but then it's going to multiply the whole thing times the 4 factorial and the 7 factorial. So if you've got, anytime you have a fraction that's got multiple things going on in either the numerator or the denominator, you have to put parentheses around all that so that it'll know that all of that is supposed to be the denominator. So you have to put parentheses. Then you put your 5 factorial times your 4 factorial times your 7 factorial. All right, so that's how it looks in your calculator. Oops, I left out my 7. There we go. All right, so I'm just going to hit enter, and that's going to give me my answer. Okay, sure, I guess we're done. All right. I'll see y'all Thursday, I guess.